Welcome back everybody. This is our first session in JEE mains previous year questions for chapter Wave Optics of class 12. Before this video we have made several videos of the previous chapter in this series and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous year. So if some of your friends are preparing for NEET and if you want some additional practice, then you can watch those videos also. And if you like these videos useful, helpful, then do press the like button, share them and subscribe to our channel. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, let's start today's video with the question number 1. And let me drag it down to the left side and adjust pen thickness. So I think, yeah, this will be okay. So starting with the question number 1, in the figure below, P and Q are two equally intense coherent sources emitting radiation of wavelength 20 meter. The separation between P and Q is 5 meter and phase of P is ahead of Q by 90 degrees. A, B, C are three distinct points of observation, each equidistant from the midpoint of PQ. The intensity of radiation at ABC will be in the ratio. So we have to find out intensity. And each point is equidistant. So let us suppose that midpoint is point O and this distance OA, that is equal to D. So here we will have that OA is equal to OB is equal to OC and that is basically equal to D. And here distance between P and Q, we can say PQ is equal to lambda. Sorry, not lambda, is 5 meter. It is 5 meter and lambda is 20 meter. Lambda is 20 meter. So we can say that PQ will be equal to lambda by 4 and OQ, we will need this distance. OQ will be equal to half of PQ and that will be basically equal to lambda by 8. And here let us assume that intensity we can say expression of the wave, the phase of P is ahead. So let's say that I of Q, so it's not I of Q, X for Q, because when we write an equation it is always for the amplitude. So X of Q, let us say it is equal to A sine of omega t. That is the amplitude of the Q source. Then amplitude of the source P will be equal to, as both are identical, only we have phase difference, so it will be A sine omega t plus 90 and that is A cos omega t. So that is the basic setup we have. Now let us start with the point B. We have to find out the intensities. So point B is at equidistance from both of these, as we can say here. Value of PB will be equal to OB square plus OP square and value of QB will be again equal to OB square plus OQ square, and we know that OP and OP is equal to OQ. So basically we will have PB is equal to QB. So as the distance is equal, as the distance traveled by the wave here, suppose here this is the distance traveled and this is the distance traveled by the OB wave, QB wave. So that distance is equal. So means the phase difference is not going to change, it will stay as it is. And if it is going to stay as it is, so then we can write that 4 point B, 4 point P delta phi is going to the same as it was original, and originally they have a 90-degree phase gap. So delta phi is going to be pi by 2. Now we know intensity relation, that I is equal to 4 I node cos square pi by 2. That's the relation we have if we have two sources of equal intensity. So from that we can write that I of B will be equal to 4 I node cos square pi by 4, and this will give us cos pi by 4 is 1 by root 2 square of that 1 by 2, and this will be 2I node. Now let us move to the point A. So for that, let me drag it. Now we are going for calculation of point A. Now we can write that PA will be equal to OA plus OP, and QA will be equal to OA minus of OQ. Now the path difference between the light traveling here, if I clear this, the path difference that light traveling from P to A and Q to A will be equal to, that path difference will be PA minus QA, and that will be OA plus OP minus OA plus OQ. So OA is cancelled and we have OP plus OQ. Now this is O. So OP plus OQ is equal to the actual distance between P and Q, and that is 5 meter, and in terms of lambda it is lambda by 4. So in terms of lambda it is lambda by 4. So this is the additional path difference. So due to this there will be additional phase difference, and that phase difference delta phi will be 2 pi by lambda into the path difference, that is lambda by 4. So lambda get cancelled and we have lambda pi by 2 as the additional phase difference. Now their initial phase difference, we have already pi by 2 phase difference available, and we have now added additional pi by 2 phase difference. So we can write that total phase difference phi total. Initially we had pi by 2, and now we have additional pi by 2. So our total phase difference will be equal to pi radian. And now if we find the intensity, so intensity at point A will be equal to 4I node cos square of phi by 2, and this will give us 0. Now solving for the point C. So for point C we will have same setup as for point A. So point C, for point C we'll have we can say path for the from the light from the point P, path of the light from the point P, or we can say PC will be equal to OC minus OP, and we can say Q of C will be equal to OC plus QO. Now PC minus QC will give us minus of OP minus of OQ, and both of these are equal. OP is equal to OQ, and that will be basically minus of PQ, and that will be equal to minus of lambda by 4. Now if we convert into phase, we will get delta phi is equal to minus of pi by 2, and our final phase for point C, phi total will be equal to pi by 2 minus pi by 2, and that is basically 0. So from this, if we calculate intensity at point C, intensity at point C will be equal to 4I node cos square of 0, and that will be basically equals to 4I. So our intensities are, for A we will have 0, for B it is 2i node, and for C it is 4i node. So it is basically 0 ratio 2i node ratio 4i node. So their ratio will be 0 ratio 2 ratio 4, and that can be written as 0 ratio 1 ratio 2, and that is option C for us. So option C is going to be right answer here. Now moving ahead, moving to the next one. Here we have two coherent sources of sound S1 and S2 producing sound waves in the same wavelength lambda 1 meter in phase. S1 and S2 are placed at 1.5 meter apart. See figure. A listener located at L directly in front of S finds the intensity at its minimum when he is 2 meter away from S2. The listener moves away from S1, keeping the distance from S2 fixed. The adjacent maxima of intensity he observed when the listener is at a distance d from the S1. Then d is. So we have to find the value of d here. And as mentioned that this distance is constant. Here distance between S2 and the point or the listener is constant and it is 2 meters. So we can say the person or the listener is moving in a circle. He is moving in a circle, that's why his distance is constant. And suppose that listener is at point P. So we can say here that S2P is constant and equals to 2 meter, and S1P is variable. So the path difference here will be, that will be S1P minus S2P. That is the path difference delta X. So we have to calculate it. Now, as per statement that when listener is at L, so he has a minima. So when listener is at L, he has a minima. So for minima, we know that path difference is equal to lambda by 2. So if it is at L, then we can write that path difference delta X, that should be equal to lambda by 2, and it will be equal to S1L. S1L will be equal to under root of 2 square plus 1.5 square minus S2L, that is basically 2 here. So from this 1.5 can be written as you can say 3 by 2, and square of that will be 9 by 4. So this will be 4 plus 9 by 4 and minus 2 here. So this will be 16 plus 9, 25, and root of that will be 5 divided by 2. So that will be 2.5 minus 2 is equal to lambda by 2, and lambda is basically comes up to be here, that is 1 meter. Now at point P, it is mentioned that it is the adjacent point and we have maximum. So for adjacent maxima, we know that the path difference should be equal to lambda. Now value of lambda is 1, we have already solved. So from this S1P will be equal to lambda plus S2P, and lambda is 1 and S2P is constant, that is 2. So that will give us 3 meters. So that is the option D. Now this is not a general answer, this is only for the point just in near vicinity or in the direct vicinity of point L, means between point L and between point P there will be no further maxima or minima. At point L we have minima, and then we will encounter the point P where we will have the maxima. There will be no further minima or maxima between these two points. That's why this condition is possible. So moving to the next one. Two light waves having the same wavelength lambda in vacuum are in phase initially. Then the first wave travel a path L1 through the medium of refractive index 1 N1, while the second travels in the path of length L2 through the medium of refractive index N2. After this the phase difference between the two waves is. So we have to find out phase difference. Now here we know that phase difference delta phi is equal to 2 pi by lambda into the path difference, that delta x, and actually this delta x is optical path length. So basically we have to calculate here a change in the optical or difference in the optical path length. So that will be in the first medium we have n1 and l1. So here delta x will be equal to optical path length in the first medium minus optical path length in the second medium. So n1 l1 minus n1 n2 l2, and from this we can write that phase difference will be 2 pi by lambda into n1 l1 minus n2 l2, and from that will be the option C. Moving ahead, in an interference experiment, ratio of amplitudes of coherent waves is A1 by A2 is 1 by 3. The ratio of maxima and minimum intensities of the fringe will be. So here we have amplitude ratio, and we know that intensity is proportional to square of the amplitude. So we can say I1 by I2 will be equal to 1 by 9, or we can write that I2 is equal to 9 times I1. Now we have to find out ratio of maximum and minimum intensity. So we know I max by I minimum is equal to under root I1 plus under root I2 divided by under root I1 minus under root I2 whole square, and this will give us we can say under root I1 plus 3 times of under root I1 divided by I1 under root minus 3 times of under root I1 square. So this will give us 4 by 1, or sorry 4 by 2 square, and we have negative sign here. So this will be minus 2 square, that will be 4 ratio 1. That is option C for us. Now moving ahead, two coherent sources produce waves of different intensity which interfere. After interference, the ratio of maximum intensity to the minimum intensity is 16. The intensity of the waves are in ratio. So here again we know the relation that I max by I minimum is equal to under root of I1 plus under root of I2 divided by under root of I1 minus under root of I2 square, and this is given equal to 16 by 1. So from this under root I1 plus under root I2 divided by under root I1 minus under root I2 is equal to 4 by 1, and when we solve this we will get that 5 times of under root I2 is equal to 3 times of under root I1, and from this I1 by I2 will be equal to 25 by 9. That is option B. In the next one, on a hot summer night, refractive index of the air is smallest near the ground and increases as height from the ground. When light beam is directly horizontally, the Huygens principle led us to conclude that it travels the light beam. Bend downward, bend upward, becomes narrow, goes horizontally without reflection. So, as mentioned here, that suppose refractive index is keep on increasing as we move upward. So we can say that suppose this represents our refractive index profile. That as the thickness between two lines or distance between two lines is getting increased, refractive index is also increasing. So what will happen? Let's suppose we have a horizontal light here. We have a horizontal light which strikes it at this point. Now, if we look it according to only a light beam of zero thickness, assuming this light beam has zero thickness, it will keep on traveling in the straight line, because for that it does not encounter any deviation in the refractive index. But suppose we have a wavefront of light. We have a wavefront of light like this. Now, for this wavefront of light, suppose this is the its center. Now, for the lower part, refractive index will be the less, and for the higher part, uh, yes, for the higher part of this wavefront, refractive index will be higher. So, it's like that here we have a denser medium, and here we have a rarer medium. On the lower side we have a rarer medium, and on the higher side we have a denser medium. And we know that velocity of light inside a medium is given by c by mu. Now for the denser part, mu is greater, so velocity will be less. So upper part will be traveling slower and lower part will be traveling faster. So what will happen? That our wavefront will bend, and it will bend like this, and it will become like this. Initially, it was wavefront was vertical. Now it is started tilted. So wavefront is it's like it has bent towards the upward. And from options, given options, you can say option B will be the right answer. So moving to the next one. Interference pattern is observed at P due to superposition of the two rays coming from the point S as shown in the figure. The value of L for which the maxima is obtained at P is, so we have to find out value of L. Now for maxima, the path difference should be integral multiple of lambda. So we can say that delta x, that will be equal to, here suppose this point is O, so delta x will be SOP minus SP. Now SP is equal to 2L, so we have to calculate SOP. For that, what we can do, we can draw a perpendicular here like this. Now this distance will be L, and this angle is 30, this is 60, so this will be 30. So this SO will be equal to L cos 30, and that will be, oh sorry, correction here, because SO is hypotenuse, so we have to take it accordingly. SO is hypotenuse, so we can say that SO cos 30 is equal to L, because SO is the hypotenuse, it is the longest side. So cos 30 is root 3 by 2. So from this, SO will be equal to 2L by root 3. And OP is also going to equal to SO. So SOP will be equal to SO plus SP. That will be basically twice of the SO, that is 4L by root 3. So here we will have 4L by root 3. And the total path difference will become 2L into 2 by root 3 minus of 1. Now this path difference has to be integral multiple for we want to have maximum, so it should be integral multiple of n lambda. So we can write it like 2L by 2 by root 3 minus 1 is equal to, and let us write path difference as n lambda. So from this, if we calculate L, we can take LCM. So this will be 2L, here we have 2 minus root 3 by 2 and is equal to n lambda. This 2, sorry, this is root 3. So from this n lambda, we have to calculate L. So 2L is equal to n lambda root 3 divided by 2 minus root 3, and you can say L will be equal to n by 2 into lambda root 3 divided by 2 minus root 3. Now if we match it, that none of the answer is directly matching, but in option C we can see that this part is matching. Means we have missed something here, and that something is reflection. Let me discuss that. At this point O, we are getting reflection, and due to reflection what happens, that there is a shift of phase by pi. So we can say initially due to this shift of phase pi, that our condition for maxima also gets shifted, or we can say condition for maxima and minima gets interchanged with each other. So originally our condition for maxima is n lambda, but due to this phase shift our condition for maxima becomes 2n minus 1 times lambda by 2, and if we equate 2n minus 1 lambda by 2 equal to the difference, that difference is this one, that is 2l into 2 and 2 minus root 3 by root 3. So that will be 2l into 2 minus root 3 divided by root 3. Now if write value of L, it will be equal to L is equal to 2n minus 1 by 4 into lambda root 3 divided by 2 minus root 3. And that is equal to option C here. Now let me clear this one. So from this we can see that option C is right here. So with this we end this video here. Hopefully whatever we have covered is helpful to you. If you have any doubts or suggestion, you can put them in comment section and I will try to resolve them. And if you like this video, then do share them, subscribe to our channel, and if you like to donate us something, you can scan any of these QR codes in front of your screen. With this, again, thanks for watching, and we will meet in next video.